Okay, so to understand Unit 6, or Lesson 6, you need to understand how solubility works. So I'm just going to recap what Lessons 4 and 5 say and see if that helps you out. So Lesson 4 and 5 is really just talking about this idea that when you combine two ionic compounds together, they may create a precipitate that is insoluble in water. So long story short, not all ionic compounds actually dissolve. So things like sodium chloride, table salt, we know dissolves in water, but there are things like calcium carbonate, which is the stuff that's left behind when you let your tap water evaporate in your cup, that's insoluble in water. And so that's what this whole basis is. So what I have in front of me is that solubility table that was on the day 10, I think it was, on Friday's assignment, and it goes through what things are soluble and what aren't. And so let me just briefly walk you through how to read it. So if you have a compound, let's say you have silver chloride, you would go down to silver on the left-hand side, across to chlorine on the top, and that you see where it intersects, we see a solid. That means you're going to get a precipitate and it's going to stay together. However, if you were to have something, let's say like sodium nitrate, we have sodium over here, we have nitrate up here, and where that intersects, it's aqueous, which means it dissolves in water. So how do we write that out, or how do we annotate that as a reaction? And so that's really what the practice problem for this is. Now, I will tell you, if you scroll down, the answers are actually there, but let me show you how to go about doing it. And I'm going to do it with number 6, because number 6 puts everything together in one problem. So when you're looking at trying to figure out what these products are going to be, the first thing you need to do is figure out how the ions are going to align with each other. So potassium, if it reacts with phosphate again, it already tells us that that produces ions in a solution. It's aqueous. If it reacts with aluminum, aluminum ions are positively charged, so the potassium and the aluminum ions are going to repel each other. So what actually happens is the potassium will go together with KNO3. So we're going to write that down. NO3 is a -1, K is a +1, and so when you get them to equal out, you get KNO3. And then we're going to put the aluminum can therefore only react with the phosphate, and aluminum is a +3, phosphate is a -3, and so we have aluminum phosphate. Now I will tell you a little secret. If you go back to that common ion chart, at the top of it, those are actually, all of your polyatomics are built into that ion chart. So if you don't want to go back and forth to a separate ion chart, it is there for you. All right, so those are our two products that we're going to get out of this reaction. So now what we need to do is we need to figure out, okay, are these going to be aqueous or are they going to form a precipitate? So we go to our chart, and our first one is potassium with chlorine, or was it nitrate? Now I forgot. I should have probably remembered that. Whoops. It's potassium nitrate, aluminum phosphate. All right. So potassium nitrate, where they intersect, we have aqueous, and aluminum phosphate, and where they intersect, it's solid. So I'm just going to go ahead and write that down here, that this is aqueous and this is solid. All right, so this is what we call our molecular equation. This just stays as it is. Now, ignore the rest of this stuff. For space, I need to use this white space. So that's our molecular equation. So now we're going to write the total ionic or the complete ionic, depending on which book you read, equation. So what we do now is we're looking at what happens when you put these things in a solution. So if we put potassium phosphate in the solution, it tells us that it's aqueous, which means it's going to break apart into its individual ions. Since there's a subscript of 3, that tells us we're going to get 3 potassium ions and 1 phosphate ion. Make sure that you're putting the charges at the top. And then we're going to get 1 aluminum ion and 3 nitrate ions. Now, I suppose I should have done this before, but we should have balanced this. Okay, so I just threw the 3 out in front to get it balanced. No harm, no foul there. All right, so now on the right side of the equation, the only aqueous thing here is K plus and NO3 minus. because, again, that potassium nitrate is soluble. Whoops, we're going to have 3 of each of those because of this coefficient. But now aluminum phosphate is insoluble. It forms a solid. So we're not going to write those as ions because it doesn't form ions in water. So now to write our net ionic equation, what we're doing is we are looking at what is in common on both sides of the equation. Well, we have 3 K pluses on both sides, so they're going to cancel out. We have 3 NO3 minuses on both sides, so they're going to cancel out. They are what we call spectator ions. And then we have just our phosphate, and I'm on my glitchy spot, so I apologize. And our, whoops, I forgot to put the aluminum charge up here, our aluminum ions, and they form aluminum phosphate. And so that is our net ionic equation. These are the only ions that do anything. They go from being free ions in solution to reacting with each other, forming a compound, aluminum phosphate, which is insoluble. So I hope that kind of summarizes what you're doing. You could ignore these solubility rules. Just use the table or the chart. It's a lot easier to understand. And if you get stuck, you can go ahead and look at the answer key to see where you may be off. But the important thing here is to make sure that when you're splitting these things, you're splitting the ions. Make sure you're taking the subscripts and making them coefficients or keeping the coefficients out in front. Make sure you understand which ones are solid. The ones that are solid do not form ions. They stay together through the whole process. And those things that are aqueous form